The question is, what is the area of an equilateral triangle whose inscribed circle has radius 2? I'm gonna start by graphing the shape. I'm gonna graph a triangle, and I'm gonna have a circle that is inside that. Let me move the circle inside the triangle. Perfect. And the radius of that circle is 2, okay? To find the area of the gray triangle, I need to have the length of the base and the length of the height. But instead of finding those, I'm gonna divide this triangle into smaller triangles by doing like this. This length is radius 2. This length is the radius, and it's 2. And I'm gonna have a small triangle. Let me make it with another color. I'm gonna have a right triangle in here. Okay, and if you notice that this is also a right triangle, and I have the same triangles in these areas as well, okay? And all of them are the same. Why? Because if you look at this green triangle in here and compare this with the next one, this one that is in here, these two triangles are congruent, high school geometry. And so this will help us to find the angles. How? This is the equilateral triangle, so all these angles in here, these are 60 degrees, okay? And so since this triangle in here and this one, they are congruent, this makes this angle in here 30 degree. And if I look at the green triangle in here and I find the area of this green one, I can multiply it by 6 and find the whole area of the biggest triangle that I have in here. But let me look at the green one in here. I have the height is 2, and now I need this one. Let me call it X. I need to find this one, but I know the angle. The angle is 30. This angle in here is 30. And I know that the tan of 30 is basically sine 30 over cosine 30, which is 1/2 over square root of 3 over 2. And if I simplify the 2's, I have 1 over square root of 3. And the tan of 30 here would be this length, which is 2 over x. So let me write 1 over root 3 is 2 over x. And based on that, by cross multiplication, x is 2 root 3. So this x in here is 2 root 3. Perfect. In this green triangle, I have the height and I have the base. Therefore, the area of the green triangle, the small green triangle, is the height times the base divided by 2, which is, if I simplify that, it's 2 root 3. And therefore, the area of the bigger triangle is 6 times that. It's 6 to root 3, which is 12 root 3. So that was a trick to solve this problem. I would like to solve one example similar to the question that we solved previously. And the example is this. What is the area of an equilateral triangle inscribed in a circle of radius 2? Okay, so what do I have in here? I have a circle of radius 2. Okay, so that's a perfect circle. and I have an equilateral triangle within the circle. So let me graph an equilateral triangle in here. It would be probably something like this. Okay, that's the center of the circle and the triangle, and it says that the radius is 2. Okay, so what is the difference between these two questions? The first question says that we have an equilateral triangle and we have an inscribed circle. So the circle is inscribed within the triangle, but here the triangle is inscribed in the circle. That's the difference between these two, but I think the technique would make sense. The technique would be the same. So I need to find the area in here, but what I'm gonna do is to use the smaller triangles. So let me make it like this to have a small triangles, and let me have oops radius 2. Okay, what I'm gonna do in here is to use smaller triangles to help me solve to find what I'm gonna do is to use the smaller triangles in here and find the area of the smaller triangles and add them up to find the area of the bigger triangle. So how I'm gonna do that? I'm gonna graph some lines like this. These are the radius of our circle, so they are 2. Okay, and then I have a right triangle in here, and definitely a right triangle in here, and I'm gonna have a right triangle in here, and since the purple triangle is equilateral triangle, the angle is 60, and then based on the high school geometry, I know that this triangle in here and this one in here, they are congruent, which means that all the angles are the same. So the angle in here is 30 degrees, and I know that this side is 2. So what I need to find in here, I need to find this height in here, and let me call it x, and I need to find a y, which is the base of this. Let me make it green triangle in here. Okay, so how I'm gonna find it? I'm gonna use the sine of 30. Let me write it in here. Sine of 30 is 1/2, and it's equal to x over the hypotenuse. So x over 2, and so using cross multiplication, I know that 2 is equal to 2x, which means that x is equal to 1. Good, I found x. Now I'm gonna use cosine of 30, which is √3/2, and I know that the cosine is y, this leg, so y over hypotenuse, which is 2. I'm working on the smaller triangle, the green triangle in here, and then I'm gonna do the cross multiplication one more time. 2√3 is equal to 2y. Now I'm gonna simplify the 2's in here, and so y is equal to √3. Perfect. And in that case, the area of the green triangle is equal to what? Is equal to the height times the base divided by 2. Now, how many of these triangles I have in here? I have 6. 1, 2, 3, 4, 5, and then 6 of them. So the area of the purple triangle is equal to 6 times root 3 over 2, which was the area of the green triangle, and if I simplify that, I get 3 root 3. Okay, great. That's the answer, the area of this purple triangle.